Ladies and gentlemen, it's Galen Ballou coming at you not live with my final project for University of Washington CSEP 590B Enterprise Chatbots. Okay, folks, this is not my first time recording the video. 10 minutes goes by real quick. So, this is going to be a bumpy ride. We are going to be cruising close to light speed. Please buckle up. If you have questions, concerns, fears for your safety, please do read the final report. That's where I will get into essentially like the glossary of terms and all the concepts about what the heck is going on in here, okay? So go read that if you haven't already. Also, I will not be doing live queries. I won't be executing this notebook while we go. That is for two reasons. Basically, queries can take a long time. There's a lot going on in here. There's a huge amount of queries because the large language models are iterative. We're putting them in recursive loops until they reach a breakpoint. And that just takes a long time. Also, I've got everything set up where we've got the responses that we're interested in to be able to highlight what we're talking about at certain points. And that's not always the case because sometimes things break. There's an issue with the output parser, it hallucinates, all that good stuff. So that's very real. I comment on that. You know, it's in the text. I'm not trying to hide it, but I also don't want to run into it while we are trying to get through stuff. So with that, let's haul ass. Okay. So what we've got here is an agent. Agents are decision-making tools, and they decide when to use tools and which tools to use, okay? So we're going to make an agent that has access to the Wikipedia tool. That tool name gets injected in input variables and then ends up in the agent's prompt. This prompt describes how the agent should behave, okay? So let's ask this agent, what's the weather like today? And we'll see, goes to Wikipedia because that's what it's got, right? And it gets a bunch of information about weather. Ultimately, it comes back to us and it says, why don't you use a weather website? Okay, not bad, but let's get the weather. Okay, so now we're going to give it access to the Open Weather Map API. Again, that will get injected into the prompt. How does the agent know which tool to use? That is through the tool definition and a field called description, where natural language description of the tool is included. This is a super powerful field. It really influences how the agent interacts with tools, right? So we can govern, for example, if you didn't have input location should be a string, the model could hallucinate all sorts of stuff, right? Also similar, if you make the input requirements too structured, you're lowering the probability that the agent will correctly, input the right information. So let's ask this chatbot what the weather's like today. Boom. Check it out. It goes to Open Weather Map. It goes to New York. We could have just as easily said Seattle. I think we'll do that later. Okay, so this is cool, but what if I want to talk about information that Chat GPT doesn't have access to, right? It's before the November 2021 whatever training date, right? Well, also, what does that have to do with the CSE course catalog? What we're going to do is we're going to take a doc, we're going to download it, we're going to parse it, we're going to make an embedding out of it, and then we're going to store it in a vector database. There's a lot going on here. There's a lot of different variables, several different algorithms. There's, I think, a whole art and finesse to fine-tuning these vector databases, and I mean, there's a ton. For the sake of the demo, we're just going to look at one parameter, which is k. K is the number of vector chunks of docs that are passed back to the agent chain. The agent chain is the large language model that's going to read each doc and see if it answers the user's prompt, okay? In terms of MapReduce, we'll look at all the chunks that get, so we'll do it 6 times. We'll take the output of each run against each chunk. We'll glom all 6 outputs together. Then we'll like put all that back into the context window and run it again against a superset of outputs, right? Okay, let's keep going. So we're gonna ask this bad boy, And I guess I should show you guys the tool definition. Here we are. Aha. So now I've passed it this custom tool called CSE lookup, and let's check out the description. Use this tool when you need to answer questions about the UW course catalog or CSE courses in general. Input should be fully formed questions. Nice. Okay. That all gets injected. What is CSE 311 about? Sorry, I can't provide an answer to this question. Huh, okay. Took about 22 seconds to run. Let's bump K up. Now we're going to pass MapReduce 12 different docs. And it's going to look for the answer in each of those docs, take all 12 outputs, glom them together, look for the answer in that one, super inference. What is CSE 311 about? Oh, look, it found it. Nice. What was the downside? Took about twice as long. Also, this one in particular doesn't always work. Okay, even with 12. Okay, so now we've got custom tools. Let's talk more about the tool description. We've already hit on this a couple times. Ba-ba-ba-da-bum. So now we're down here, and check this out. We're going to look at the custom tool again, but I've removed a line that defines how the input should be formed, right? So there's a line missing here for the custom tool. I'm going to ask it a question. It finds that it should use the custom tool, the CSE lookup, and notice the action input. So this is what's being passed to the tool. Okay, interesting. Doesn't find it. All right. Now, let's add back in this line. Input should be fully formed question. Okay. We'll ask this agent the same question again, and note that the action input is a fully formed question, right? Boom, and we get back an answer. So I think what's critical here is that when everything is natural language, phrasing becomes extremely important. Small differences can yield very different results, right? Okay, we're getting there. Let's blast through some of the tools that this agent has access to. So we've got Wikipedia. What can you tell me about the moon? Holy smokes. So it takes all this information, pulls the whole page, provides a summary. Also, what the heck? Summary moon sen. Oh, separate page. I'm confused. It's not. Nice. Okay, we've got math. We have a calculator. This is underneath the hood. This is actually using the Python REPL tool. So this is a tool that calls a tool. But check this out. Natural language. What is 13th raised to the 0.3432 power? Boom. And yes, that is correct. Okay, so here's the Python REPL under the hood. Natural language. What's the output of this list comprehension? Check that out. So it is legitimately running Python through the tool interface, right? And the agent is deciding, oh, this looks like a good use case for the Python REPL tool. We've got Wolfram Alpha. Nice. Do a little algebra. Love that. We've got terminal or shell. So I'm going to ask it to print the working directory and list the files where we are. And I ran this from here we are. Here's our notebook right here. So we're quite literally in this working directory right here. And there are the files. So it's actually interacting with the file system on my computer. And then I get some weird validation error, but gorgeous. A news API. What are the top headlines today? This one is super interesting. Check this out. So action input, what are the top headlines today? It says, okay, we're going to do that in the news API. So the agent here, this is all natural language, right? It's talking to itself. The API call was unsuccessful because it required parameters are missing. The necessary parameters are resources, queue, language, country, and category. Where did this come from? This came from the chain, from the previous output, right? This input being put into the news API, produced a tool output, which had a bunch of gobbledygook about how the API call didn't work, right? The language model looked at that and basically produced a fix. Let me modify the previous action to include the necessary parameters. Headlines today from USA. Oh, we got some headlines now. And it decides the response seems accurate and helpful. I can return that. Oh, look, I even get a link. Nice. Okay, we've got weather. Now we're going to look somewhere specific. Now we're looking in London. Boom, London. Love that. Okay. If you're curious, 12.8 degrees centigrade. Who the fuck knows what that means? It's probably cold. Lastly, let's do a bunch of query examples from CSE 142. This is using a K value of 12. So things are probably taking, 30, 40 seconds to run at a time. So not performant, but very cool, beautiful natural language responses. Honestly, I need to actually hardcore validate some of these. Like, I know that they're not all correct, so we're gonna cruise down here to some of the last ones. Yeah, we probably don't want to look at all these. We are over time. Holy shit. Do you know any courses that jointly offer with EE? And it just says that there's this one. So obviously it's not right all the time, but damn, is the output nice. Nice and slow. And lastly, I just want to highlight how powerful agents are because they can do multiple things. So who is the president of France married to? What is their age raised to 0.43? Check this out. The agent will break this down into steps. First, go to Wikipedia, find out who the spouse is. He does this. I need to calculate the age of the spouse. So it finds out who they are, it finds out their birthday, and then it plugs that into the calculator. Bridget Macron's age raised to the 0.43 power is approximately 6.14. Awesome. This is just a two-step process. This can go completely off the rails. Yes. Mind blowing. I love it. Okay. Yeah, we're over. Take care.